One of the most exciting and historical activities we offer at the Knights in the Classroom is our siege weapons experience. This video will explore the process of building our catapult and discuss the educational components involved. I'm Sir Matthew and I'll be detailing the construction elements.
And I'm Lady Andrea, and I'll be sharing the educational components.
When we first started this project, it was decided we would not use the internet as a resource, as it's not always reliable. We decided instead to only use historical resources, mainly books we had available to us. The catapult dates back to 399 BCE and was first developed by the Greeks. It looked very different, more like a giant crossbow, and would lead to the development of that weapon as well. The type of catapult we built was first designed by Archimedes. We started with a basic build using 2x4s and screws. Yes, screws are not historically accurate, they would have used nails or pegs, but we must keep things safe for demonstrations at schools.
As you can see here, a screw, which is an inclined plane wrapped around a shaft, is an improvement over a nail or peg because it is capable of fastening things more securely. One of the earliest screws, although used for a completely different purpose, was also invented by Archimedes. One of the things you'll notice about the design is the number of triangles used to create structural strength and stability.
Once the basic structure was built, including the throwing arm, we had to string the catapult, which was a very long process. Once it was strung, the rope had to be tied securely and wound. Then it was time for testing.
The stored energy in the torsion of the rope is the catapult's power source. The tighter the torsion rods are turned, the greater the power.
It didn't take us long to realize we lacked sufficient power. Our next step was to investigate different types of ropes. We even tried modern parachute cord in the hope that the elasticity would provide greater power. Did I mention the stringing took a long time? 4 hours each time we restrung it.
How much rope we used also influenced how much power the catapult could store, but we were limited by the size of the hole on the outside frame as to how much rope we could use. We used a figure-8 pattern when stringing the throwing arm.
Time for more testing!
We then explored changing the trajectory by lowering and moving the cross brace so that the throwing arm struck the cross brace at a different angle, which would increase the arc of the projectile, hopefully increasing power.
Followed by more testing. We again tried changing ropes, this time hoping something more natural would yield greater results. It made no difference. We even tried adding another rope to the equation, the synthetic one, to try and add extra oomph. Nothing worked. Version 2 saw us move the cross brace and supports to the front of the catapult. We also drilled new holes for the rope. You'll also notice the throwing arm has a new look. It turns out you can't necessarily trust historical texts for accuracy either. Even though many resources show baskets or spoons on catapults, there is nothing to support the theory that they were actually used. However, there are resources demonstrating our new net-like device. We actually tried a couple of different nets, and they visited a few schools before their limitations became apparent. Historically speaking, a catapult, or onager as ours specifically would be called, was designed to only last the duration of one battle. We were trying to build something that would survive many uses, so it was back to the drawing board and time to find some help. Version 3 was basically a complete rebuild. This was after consulting a few family members who are engineers, and finally consulting a friend who we would consider a siege weapon expert, a gentleman with Canadian military background who built our crossbow. He guided us on the redesign of what would be our final version.
With version 3, our goal was to overcome two major obstacles: to increase the power of the onager so the payload would travel further, and to maintain historical accuracy. It also had to be safe and portable.
To achieve this, we had to completely redo the base, using 2x6s instead of 2x4s. We moved the cross brace and supports to the very front of the onager. The holes for the rope were made larger than ever before.
Additional supports were installed to ensure the catapult didn't implode under tension. The cross brace was also lowered while the throwing arm was lengthened to increase the throwing arc. We added legs to the onager because we had a brand new release mechanism which required ground clearance and a great deal of trial and error to find the correct point of release. Instead of a net or basket, version 3 featured a leather sling to hold the payload. We now had more power and more moving parts than ever before. The new design would require a pin to release the stored energy of 200 feet of rope.
Fire. That's what it's all about.